Good morning. This is Naz from NB Network Lessons. Hope everyone's doing okay. Today is a really important day in history for us in Texas. We're going to be seeing a solar eclipse, full solar eclipse around 1:40 p.m. Central Standard Time today. And I'm hoping that clouds will go away because some of the weather folks are forecasting that there might be some clouds in the way, which might make the view, not that good. But I'm still excited and optimistic that hopefully, we'll have a good view. I'm excited. I'm ready for that. I got my ISO approved glasses to see that. If you live in Dallas area, don't, go ahead and enjoy that. But make sure that you have ISO approved glasses. And also, I don't know, I think I'll keep my pets inside. All right. Anyway, that was just a side thing I wanted to mention. But today's topic is going to be calculus lesson number 40. And we're going to discuss what hyperbolic functions are. Because in my next lecture, I'm going to go ahead and show you some of the equations derived for hyperbolic functions. And I'm not going to actually derive them. I'm just going to go ahead and write them down. But the derivation of those equations, hyperbolic, should be in your book. Okay, so feel free to go ahead and browse through them. But let's go ahead and take a look at hyperbolic function. The way I want to approach is that I want to show you actually the difference between trigonometric functions and hyperbolic functions. I think it'll make sense in that way. So let's go ahead and look at the trigonometric function. Let's say you've got x-axis and you've got y-axis right here. All right, and I draw a circle. Okay, and let's say the radius of this circle is 1. Okay, this is my x-axis and this is my y-axis. Now, in case of trigonometry functions, you will see that x square plus y square is equal to 1. All right. If the radius is 1, then your x square, x-axis right here, okay? And then you've got your y-axis, which is going to be basically kind of like right here. So that is going to be 1 if you do a square of x and y. So then, if that's the case, we can write this as cosine square of x plus sine square of y is equal to 1. All right. Now let's look at the hyperbolic function. How does that look like? So in case of hyperbolic function, let's say we have x-axis, we've got y-axis, x-axis, y-axis. So hyperbolic function is going to kind of look like this. So this is your hyperbolic function, okay? So if you go ahead and, write the equation for x squared plus y squared, it's actually x squared minus y squared is equal to 1. So there is a similarity, and you can remember it, that in case of trigonometric function, in case of a circle, it's plus, but when you're trying to solve hyperbolic function problems, the sign is minus, okay? Then I can write this down as cosine h. Now h stands for hyperbolic, okay? Cosine of h square x minus sine of h square of y is equal to 1. Again, difference of sign. Over here you have plus, over here you have minus, but you have h, which stands for hyperbolic function. So this is what I wanted to introduce you in this lecture. in my next lecture, I'm going to write the equations from your book and their derivatives, and then we will use them to solve problems. All right. Thank you so much for watching. Stay safe. Have a nice day. I'll talk to you later. Bye-bye.